Hello and welcome to the chapter on numbers for GCSE, and we'll start with all types of numbers here. So let's go through them one by one. Some of them may not be directly relevant to your syllabus, but I just mentioned it in case you want to know what are the remaining ones. So let's start with natural numbers. All the numbers that start from 1 and go on are called natural numbers. Any numbers which start from 0 and then go on till infinity are called whole numbers. And if we include the negative numbers as well, then they form integers. So all the positive and negative numbers and 0 constitute integers. Now if we want to show all these numbers on a number line, then we just have to draw a straight line, and there is a red mark at the center there which we call 0, and we have equidistant marks called 1, 2, 3, 4 on the right hand side, and -1, -2, -3 on the left hand side. So this is called a number line. We can also show some numbers in between, which I have shown with dashed lines, like -0.1 or 1.5 or 3.8. So all these numbers can be shown on a number line, and usually when we draw it horizontally it's called an x-axis, and if we draw it vertically it's called a y-axis, and we'll see that later on. Now, what are rational numbers? Any numbers that can be written in the form of p by q are called rational numbers. Here p and q are integers, and q should not be equal to 0, because if it is 0 then the number won't exist. So examples are 5 by 7 and -22 by 57. We can keep writing whatever we want, just that the denominator should not be 0. So these are some of the numbers. Then we go on to some other types of numbers, like irrational numbers. So we just saw rational numbers are some things which can be written in the form of p by q. So automatically the irrational numbers are the numbers that cannot be written in the form of p by q. So examples are pi, square root of any prime number should fall into this category, and Euler's number. So all these, whatever we write here, are the approximations. For example, pi is written as 3.41, or it's also written as 22 by 7. That is an approximation. 22 by 7 is not exactly pi. So pi cannot be written in the form of p upon q. Same goes with the other numbers shown here. Okay. Now, what are the real numbers? Real numbers are nothing but the combination of rational and irrational numbers. When they are put together, they form a bigger group called real numbers. Now I'm just adding two more here, though they are not directly relevant to your syllabus right now. So because we say, oh, real numbers, everything falls in the category of real numbers. So there are numbers which are unreal or imaginary. Okay. So for example, there are no numbers which can have a square root of negative numbers. So any number which has a square root of a negative number is called imaginary, because in real life we cannot have such a number, but they are used in some solutions when we try to find out some solutions that we will see later on, not in GCSE. So we will see that these are imaginary numbers are used, and they are nothing but the square roots of negative numbers. Let me put that simply here. And which can be changed into a square root of a real number multiplied by square root of -1, as shown here, and this square root of -1 is called iota. So any number with an iota is called an imaginary number. And what are complex numbers? Any combination of real and imaginary numbers are called complex numbers, because they are not really something which exists in real life, okay, where we count things. So x plus iy is a generic complex number where x and y are real. However, when we add I there, then the whole of this number does not stay as real. So that's why x plus iy is a generic form of complex number where iy is imaginary and x is real. However, when we add imaginary to real, the overall it becomes complex. Okay, so let's move on to few other number types. The other one is prime numbers. Prime numbers are the ones which cannot be divided further except by 1 and itself, which is always the case with any number which can be divided by 1 and the number itself. So these numbers are in the lowest form and cannot be divided further. So these are prime numbers. Now, what are prime factors? So any number can be divided into smaller form, and this is smaller form if these smaller numbers are prime numbers, then these factors are called prime factors. For example, number 30 can be written as 2 into 3 into 5. Now here 2, 3 and 5 are factors of 30 and they are prime numbers as well, because neither 2 nor 3 nor 5 can be divided further. So we can say 2, 3 and 5 are the prime factors of 30 because they are factors of 30 and they are prime numbers as well. So they are prime factors of 30. Just to note here, 6 is also a factor of 30. However, 6 is not a prime number. So 6 is a factor but not a prime factor. Okay. So let's move on to the big picture. When we show the big picture, all the numbers can be divided into real numbers and complex numbers. Now real numbers can be divided into rational numbers and irrational numbers. Rational numbers have integers as their subset. So integers plus the fractions, the proper fractions I would say, constitute the rational numbers. So integers are just the numbers, okay, minus infinity to like minus 5, minus 4, minus 3, minus 2, minus 1, 0, 1, 2, 3, 4, 5 up to infinity. These are integers. Now if we consider only from 0 up to infinity, they are whole numbers, so they are part of integers, and natural numbers are the numbers from 1 to infinity. So if we remove 0 from whole numbers, it becomes a set of natural numbers. Okay, so this is the set of whole numbers. Now once we know what the numbers are, as we just saw, we need to do something with these numbers. For example, we need to add them, subtract them, multiply them, and we'll see what are the powers. I don't know if most of you have seen it or not. However, 5 into 5 is 5 square, 2 into 2 is 2 square. So any number multiplied by itself is a square, and the rule for doing any operation is called the Bodmer's rule, where we need to follow this order. First of all, we need to solve whatever is inside the bracket, and then we need to solve the power order, which means square or square root or whatever be the power of the number. Then we go on to division and multiplication, and finally we do addition and subtraction. So if we solve this equation, what do we want to do first? Here we have 5 square plus 35. In bracket we have 2 square multiplied by 3 plus 5. So now going by the above rule, which is the Bodmer's rule, what we do is, first let's keep 5 square here plus 35. We try to solve the bracket first, okay, everything inside the bracket first, and inside the bracket we have order, we have multiplication with 3, and we have addition with 5. So let's solve the order first, which is 2 square, which is 4, okay, multiplied by 3 plus 5. So this becomes 5 square plus 35 into, first we will do multiplication and then we will do addition, which means 4 into 3 is 12 plus 5, and this goes as 5 square plus 35 multiplied by 17. Okay, now again we have to do the order first, which means 5 square is 25 plus 35 into 17. Again multiplication first as per the rule above. Before addition we'll do multiplication. So it is 25 plus 35 into 17. Okay, so 35 into 17 is equal to 595. So it comes out as 595. So the answer becomes 620. So this is how we solve step by step following the BODMAS rule. Okay, so let's finish the numbers here, the theory part of it. Next we will move on to the solutions to some common problems which are very basic, and in the last video we'll try to pick up some of the complex problems on this topic. Okay, so that's how we'll do. First the concepts, then the basic problems, and finally the complex problems. So I hope you have understood so far, and if you are interested, let's move on to the next video. Thank you very much, and bye bye.